Hey, this is Math 6, Unit 2, Lesson 7, creating double number line diagrams. So we're continuing our talk about double number lines again. So here we go. We're going to become a pro this time. So hopefully you can go to pro status at the end of today's lesson with your double number lines. All right. So first off, ordering on a number line. It says locate and label the following numbers on the number line. We have a half, a fourth, 1 3/4, 1 1/2, and 1.75. So we have decimals, we have fractions. All right, we can do this. If you wanted to think them all as fractions, you could. If you want to think them all as decimals, you could. It just depends on what you want to do. I'm going to, first of all, what I decided to do is I said I'm going to take this line which goes from 1 to 0, 0 to 2. I'm going to cut it in half and drop a 1 right here so I know about where halfway is. Is that fair enough? Okay, that's pretty fair. Now from here, I know I have 0 to 1 and 1 to 2. Everything is broken up into, I can see basically I have fourths, right? All the way through, which means I take my one space, and I need to have 4 sections in it, right? I can divide it in half right there, and then in each one of those in half again. So half of 1 is a half, and half of a half is a fourth, right? So I have 1/4, I have a half, which is the same as 2/4, and then I have 3/4 right here. I do the same thing over here, and I draw that line there, and this becomes 1 1/2, or as a decimal, 1.5. And this becomes 1 1/4. And over here I have 1 3/4, which as a decimal is 1.75. So I have my half located here. I have my 1/4 located there. My 1 3/4 is here. 1 1/2 is up there. 1.75 is also there, which matches 1 3/4. Okay, so this is helping you see that you can take a number like space from 0 to 2, and you can actually break it up into smaller segments if need be. That's going to be important today as we actually have to work a little bit backwards, so to speak, you know, where they give us a larger number which may not be the smallest ratio possible, and we want to go a little bit further down that way. So base your number, replace numbers. Okay, label 4 more fractions or decimals on the number line. Okay, so we can do some more decimals here, 0.75. We did some more already. We could do 1.25. 0.25, 0.50, and this could be, technically this could be 4/4 if you wanted to as well. So there's some more, we're good to go. Let's take a look at activity number 2. The other day, we made green water by mixing 5 milliliters of blue with 15 milliliters of yellow water. We want to make a very small batch of the same shade of green water. So we want to make a small batch this time, right? We need to know how much yellow water to mix with only 1 millimeter of blue water. So instead of doubling or tripling our batch this time, now we're going to be shrinking it down and cutting it into smaller equivalent ratios. We want less this time. So I know that I have my ratio I'm working with is 5 to 15. That's excellent, great, no problem. And we can see here they put the hash marks on here for us. Hope you can see those there. So we have 1, 2, 3, 4, 5. So my number 1 would go right here. And I can go ahead right now and even add in the matching hash marks on this double number line. Okay? Because we're going to need to find out how much yellow anyways. So I know 1 is blue, 1 blue here. And the question is, what's going to go down for the yellow down below? Okay, so if you think about it, well, let's do the questions. We'll go in order. On the number line for blue water, label the 4 tick marks as shown. So we labeled them there, and so here we have 1 and 2 and 3 and 4 and 5. On the number line for yellow, draw and label tick marks to show the amount of yellow water needed for each amount of blue water. Okay. So, how do you want to do this here? Well, last time we went from 5 to 10, if we're going that way, what did we do? We multiplied by a number, both the top and the bottom here, to get to that number over there. 5 times 2 is 10, 15 times 2 is 30. So if I'm increasing something, I'm going to multiply it by a whole number. If I'm going to decrease and go 5 down to 1, okay, there's 2 ways of thinking about it here. I could think about it as dividing right? Because to go from 5 to 1, 5 to 1 is the same as 5 divided by 5. And 5 divided by 5 is equal to 1. So I can think about this being as divided by 5, right? So 5 divided by 5 gets you to 1. I could also think about it as 5 times 1 over 5, if I want to think about it as multiplication. That works as well, okay? So both of those are actually okay. So I can still do multiplication. This is multiplying by the reciprocal. So instead of doing divided by 5, I could think about it as being multiplied by 1/5. So here I'm multiplying by a whole number greater than 1, and here I'm multiplying by a number less than 1. So when I look at how much yellow I would need, there are two ways I could do it. I could do 15 divided by 5, or I could think about it as 15 times the reciprocal, 15 times 1/5. That works as well, because 15 times 1/5 is what? 15 over 5, which is 15 divided by 5, which is 3. And 15 divided by 5 is still 3. So both ways work, and it's good to kind of have in your mind that they are the same thing actually. So how much yellow would I need here? I would need 3 milliliters of yellow for that to work. How much yellow water should be used for 1 millimeter of blue? Oh, sorry, this one. Okay, sorry, I wrote my answer for there, there, which goes here. So 3. There we go. Sorry about that. And number 4, how much yellow water should be used for 11 milliliters of blue water? Now what's nice is this. What have we just created? Well, we've already said that for every 1 blue, there are 3 yellow. And I could write here if I wanted to, blue, yellow. And what I want to do is I want to find out, now that I know that, I know this ratio 1 to 3, and it's equivalent to 5 to 15, the question is how much yellow should I use for 11 blue? 11 blue. Now 11 blue would be over here, right, at 11. And here's the yellow that I don't know. That's my question mark one right now. So doing what we did last time, we could think about, okay, if I have 1, what's it take to go from 1 to 11? 1 to 11 would be 1 times 11, right? You okay with that? Just like before? So how do I go from 3 to this y right there? If it's vertical, it's going to be the same multiplication process. So what is 3 times 11? 3 times 11 is going to be 33. Alright, does that make sense there? 3 times 11 gets you 33, so this y becomes a 33. That's why I erased the y and put a 33 right there. Again, another way of thinking about it is, what am I counting by here? 3, 6, 9, 12, 15. I'm adding 3 each time. So what is 30 plus 3 more? It's 33. The difficulty with using addition is that it doesn't always work out as nicely or cleanly. It's just a lot safer to play with multiplication or division here, or multiplying by the reciprocal. It just works better long term for what we're going to be doing with the next activity. So it's best not to be count up by 3s and whatever, just use multiplication stuff. The next question says, how much yellow water should be used for 8 milliliters of blue water? Okay, so if 8 is going to be on here, here's 6, 7, 8, 9, here's 8. The question is, what number would go right there with that one? I go back to what we had before, right? We already decided that we have a nice ratio of 1 to 3. Let's keep using that. Knowing that ratio of 1 to 3 helps me set up an equation like this, or at least a process like this. If I know I have a ratio of 1 blue to 3 yellow, and I want to get that equal to 8 blue, and I don't know how many yellow, we could call that X number of yellow there, right? Then I think about 1 times what gets you to 8? 1 times 8, and what is 3 times 8? 3 times 8 is 24. So it would take 24 milliliters of yellow to make the same shade. I can put that back down here again, put that on my little double number line. I'm at 24. Again, I could add up by, by threes, 15, 18, 21, and 24 to make sure I got it right, but the multiplication sure did work pretty simply. So why is it useful to know how much yellow water should be with 1 milliliter of blue water? Because that gave us a easy ratio to use and to multiply to find the the missing amounts. So we could just multiply that 1 to 3 ratio, 1 to 3. We could use that number and multiply it to get whatever other missing number we wanted to know. So it made it really easy to find the ratio we needed. Okay, let's look at 7.3. Art paste on a double number line. All right. A recipe for art paste says, for every 2 pints of water, mix in 8 cups of flour. Follow the instructions to draw a double number line diagram representing the recipe for art paste. It says first, use a ruler to draw 2 parallel lines. All right, I don't have a lot of space here. Hopefully you use a different piece of paper, but I'm trying to put it on one sheet for you so that we're all on the same idea. So here we go, 2 parallel lines. Great. Label the first line pints of water. Okay, pints of water. Label the second one cups of flour. Sure, cups of flour. All right, those are my labels there because I have a little bit of space. Draw at least 6 equally spaced tick marks that line up on both lines. All right, so 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Are they equal? It's close enough for today. All right, along the water line, label the tick marks with the amount of water in 0, 1, 2, 3, 4, 5. Okay, so here we go. 0, oh, batches, not just the numbers, but 0, 1, 2, 5. Okay, so here are my batches. My batches are 0, 1, 2, 3, 4, and 5. So how much water is in 0 batches? We'd go with 0. How much flour is in 0 batches? We'd say 0. Okay, so I know that in my recipe I have 2 pints of water, 8 cups of flour. Okay, so water in one batch. I'd have 2 water and 8 flour. That's my one batch. 2 water, 8 flour. That's one batch. Now I want to use this to then figure out what my other numbers are going to be, right? Is that the idea? I think that's the idea there. 2 pints of water, 8 cups of flour, and we're good to go. And that's one batch, as far as we can tell. Okay, label the tick marks, amount of water in 0, 1, 2, 3, 4, 5 batches. Okay, so 2 to 8. So in 2 batches, we're going to double that up. This becomes 2, 4. And then 2 times 3 is 6. And 2 times 4 is 8. And then 2 times 5 is 10. So my batches are counting up by 2. And down here, we're going to count by 8. So I have 8, 16, 24, 32, and 40. All right. So I did it right now by using the idea that one batch was a 2 to 8. Okay, and I'm going to say it's equal to one batch right now. On my notes, when I'm looking at my notes, on my notes I reduce this down to 1/4 equals one batch. Okay, so my notes I did it this way initially, but right now what I'm doing it 2 to 8. I'd have to look back at the teacher's guide to see which way they wanted you to do it. But with your partner, they might have done 1/4 and you might have done 2/8. So take a look at what you did and what a neighbor did and see if you did anything differently there. Okay? But either way, we can still answer the questions here because it's still going to be okay. So use number line to answer these questions. How much flour should be used in 10 pints of water? So in 10 pints of water, we use 40 cups of flour. And we can see it right there. How much water should be used with 24 cups of flour? So here's 24 cups of flour, and the water is right here at 6 cups of water, or 6 pints of water there. How much flour per pint of water does this recipe use? Now this is a great question because when it says how much flour per pint, this means for 1 pint of water. Okay, what we figured out was already, we said that our flour per water was already going to be 8 cups of flour per 2 pints of water. But now we're wanting to know when it says a per pint, we have to make that smaller now. We're going to have to then take our ratio and get that down to what happens right here. That's what it's asking me there. Okay? I know the 2 and the 8, so the question is what happens on this spot right there? That's going to help me figure that out. So to do that then, instead of over here we multiply by 2, we're going to want to multiply by the reciprocal, or yep, that's right. So we're going to, or divide by 2. So we can do 24 divided by 2, which gets you the 1 pint of water. And then on the bottom we do 8 divided by 2, same thing, to give me 4 cups of flour. So for the per pint, we would say 4 cups of flour per pint of water. And that's what it's asking you in this final question. Can you put it back down into a so one of these has a 1. In this case here, the pint of water is a 1, and that becomes a 4. So it's a great little question there to help us get it back down to this 1 to 4 ratio. And you can see here, here's our 1 to 4 ratio right there. Okay? So great little question there. All right. Okay. I'm going to skip the Are You Ready for More for now. Let's go to number activity 4. Why? Because it's revisiting tuna casserole, and it's getting close to dinner time as I'm working on this. So let's see that it is tuna casserole. Man, it was a big casserole last time. Looks like we have some leftovers. The other day, we looked at a recipe for tuna casserole that called for 10 ounces of cream of chicken soup for every 3 cups of elbow-shaped pasta. Draw a double number line diagram that represents the amount of soup and pasta in different size batches. Alright, so double number line. We can go like this. We can draw a nice line like this. We could draw one right below it like this. Okay, and we can call this one soup. We can call this one pasta. Alright, looking pretty good so far. So here's my 0 and my 0. And we had 10 cream of chicken for 3 pastas, elbow-shaped pastas, just like that. I could continue that around and say let's go with 20, let's do a 30, and let's do a 40. Let's do a lot more there, right? So by 10, here we're counting by 3, and with 3, 6, 9, and 12. Looks like a lot of fun there. If you made a large amount of tuna casserole by mixing 40 ounces of soup with 15 cups of pasta, would it taste the same? So same would be what? Equivalent. So would 40 soup to 15 pasta be equivalent to our original recipe, which is 10 soup to 3 pasta? That's the question. Are those equivalent ratios? If it's an equivalent ratio, it should line up on our double number line, right? So here's 40 soup, and what does it line up with? 12. That is not going to be 15, right? 15 would be over here, counting up another one. 15 would line up with what? 50, actually. So this would be a different taste. It would not be the same recipe. Just not going to quite work out there. And we could look here vertically or horizontally and say to go from 4 to 10 is going to be times 1/4, or divided by 4. And then 15 divided by 4 times 1/4 is not 3, and so it's not going to work out there, right? All right. Or I could think about the other way. I could say what I know, 10 to 3. Does it get me to 40? Sure, times 4. What's 3 times 4? 3 times 4 is 12, which is why that is there, but it doesn't match that. It's different. Number 3, the recipe calls for 6 ounces of tuna for every 3 cups of pasta. Oh, add a line. Oh boy, here we go. So not just a double number line, now we're going to make a triple number line. Oh boy, what am I going to do with myself? All right, so this is going to be for the tuna. So I still have 0, and it says for 3 pasta, 3 pasta, I have 6 tuna. So tuna is 6 right there. I can add my hash marks to line up beneath these guys here. And again, this tells me what I'm counting by. I'm counting by 6s. So I have 6, 12, 18, 24, and 30. How many ounces of soup mix should you mix with 30 ounces of tuna to make a casserole taste the same? So here's my tuna, which is 30. How much soup do I need is up here. There it is up there. We would say that we need 50 ounces of soup. Okay, so it's pretty nice to look at that double number line and take a look at how things line up. Pretty handy. Could I solve that one using a ratio and not a double number line? Yep, right? I could say that the tuna to soup ratio is a 6 to 10 ratio. And if I want that equivalent to 30 ounces of tuna, put 30 up there, I want to see how much soup I need. So to go from 6 to 30 is times 5, and 10 times 5 is 50. So I can solve it just like that, looking for, making sure it has that same relationship. Okay, so that is the idea. Let's take a look at your summary before we jump into tonight's homework. Just some guidelines here. So here's some guidelines when drawing double number lines. The two parallel lines should have labels that describe what the numbers represent. So make sure you have labels for your number lines. Eggs, milk. The tick marks and numbers should be spaced equal intervals. So make sure you do it neatly so they line up vertically. That's important. And then numbers line vertically make equivalent ratios. So if they line up vertically, they make equivalent ratios. That's the whole point there. So these are going to all be equivalents. 20 to 5 is going to match 4 to 1. That's the way it works. Okay? All right, I'm going to pause there and let you work on your homework, and we'll come back together in just a moment. All right, here we go for homework. A recipe for cinnamon rolls uses 2 tablespoons of sugar, 2 tablespoons of sugar, per teaspoon of cinnamon for the filling. Complete the double number line diagram to show the amount of cinnamon and sugar in 3, 4, and 5 batches. So, one recipe has 2 tablespoons, 2 tablespoons of sugar per, back it up. 2 tablespoons of sugar for 1 teaspoon of cinnamon, right? So that's my recipe. Even though it read 2 to 1, they write it here 2 to 1 like this. Got it. Okay, so we have our batches. I can even write down the word batches on top again. And this is 1 batch, 2 batches, right? And I can make another tick mark here. 3 batches, 4 batches, and 5 batches. Okay, the cinnamon is increasing by 1, so we can go 1, 2, 3, 4, and 5. And what we're doing here, we seem to be multiplying by 2, so 2, 4, 6, 8, and 10. Alright, and that's actually all there is to it there, right? So my batches are up here, just kind of verifying. And I have my equivalent ratios all the way throughout for up to 5 batches of the cinnamon filling for the cinnamon rolls. Okay, number 2. 1 batch of meatloaf contains 2 pounds of beef and ½ a cup of breadcrumbs. Complete the double number line diagram to show the amounts of beef and breadcrumbs needed for 1, 2, 3, and 4 batches. Alright, so we're going to have 1, 2, 3, 4 batches. 1, 2, 3, 4 batches. 1 batch of meatloaf, we have 2 pounds of beef, so we have 2 for there. And we have ½ a cup of breadcrumbs there. Alright, so now I have whole numbers and I also have fractions here. Not a problem, we can do this here. So, in terms of my batches, I'm just going to make a little note here. I have batch number 1, batch 2, batch 3, and batch 4. So, I'm going to start with 2. To make a second batch, I'm going to double it. So 2 times 2 is 4. And then 2 times 3 becomes 6. and 2 times 4 becomes 8. So I know my beef amount for batch numbers 1, 2, 3, and 4. Now over here, if I do a half and I double it, half times 2. Well, let's take a note here. What is 1/2 times 2? 1/2 times 2 is equal to 2 over 2, which is the same as 1. So when I double it, I get 1 cup. Okay? Well, the next one is, what is 1/2 times 3 if I triple that? I get 3 over 2, which is an improper fraction. If I write as mixed, I have what? 1/2. So here's 1/2 cups. And the last one, 1/2 times 4. 1/2 times 4 is 4 over 2, which reduces to simply 2. Okay? So those are my equivalent ratios for the batch of meatloaf, and I can make 1, 2, 3, or 4 batches of meatloaf there. Number 3. A recipe for tropical fruit punch says combine 4 cups of pineapple juice with 5 cups of orange juice. Create a double number line showing the amount of juice for 1, 2, 3, 4, and 5 batches of the recipe. Alright, let's do this here. And when you do it, I'm going to save some space for part B here, but here's 1, and here is 2. Alright, and here's my 0 spot. So 0 and 0. I'm going to have pineapple juice here, and I'm going to have orange juice here. I'm going to have my recipes here, which are my batches. I have batch number 1, 2, 3, 4, and 5. And batch number 1, 2, 3, 4, and 5. I can make a little number up here just to keep track. 1, 2, 3, 4, and 5. So in my first batch, I have 4 cups of pineapple, and I have 5 cups of orange juice. If I'm going to double that up, then I'm going to do 4 times 2 becomes 8. I can do 5 times 2, which becomes 10. If I'm going to triple it, I do 4 times 3 is 12, or 5 times 3 is 15. Times 4, 4 times 4 is 16. 5 times 4 is 20. And then do 5 times it. 4 times 5 is 20, and 5 times 5 is 25. So now I have the amount of cups of orange juice and pineapple juice needed to make various size batches, 1 to 5. If 12 cups of pineapple juice are used with 20 cups of orange juice, will the recipe taste the same? So if I use 12 cups of pineapple, with 20 cups of orange juice, will the recipe taste the same? Well, do those numbers line up vertically? Do we see a vertical connection here? Nope, we're diagonal. If it's not vertical, then the ratio is not equivalent, and so it won't taste the same. What would actually happen would be this one has more orange juice than that. It would taste more like orange juice and less like the right mixture. It'd be too orange juicy, so to speak. So it wouldn't quite work out too well. On part C, it tells us that the recipe also calls for 1/3 of a cup of lime juice for every 5 cups of orange juice. So it wants us to add a line to our double number line here, and that's my 0, and it says that it's 1/3 of a cup for every 5 cups of orange juice there. Alright, so we want to then put the 1/3 and continue that on with our double number line. So again, I think about 1/3 times 2 becomes 2/3. So this is 2/3 here. 1/3 times 3 becomes 3/3, which is 1. So 1 whole cup there. 1/3 times 4 is 4/3, or 1 1/3. And this becomes 5/3, which is 1 2/3. Again, probably back to the reason why we had that warm up with the fractions, to start working with our fraction stuff there. Okay, and that is it for that question right there. Let's take a look at question number 4. Tells us one batch of pink paint uses 2 cups of red and 7 cups of white. Okay, so we have 2 red for 7 white. You made a large amount of pink paint using 14 cups of red. 14 cups of red. Oh my goodness. Alright, so how many batches of pink paint did she make? Well, What we looked at before when we made our double number line, when we went like this and like this, what we saw was that if I had 0, 0, and I had red and white, and I knew a batch was 2 and 7, we were talking about our batches being 1, 2, 3, 4, 5, 6, 7, right, and so on and so forth. We made the numbers up above our number line to help us kind of see what we were doing. If I, oops, oh, I went one in the wrong spot. This was 1 right here. 1, 2, 3, 4, 5, 6. If I wanted to make 2 batches, what did I say? I would double this number, 2 times 2 to make 4, and 7 times 2 to make 14. Okay? And what's happening here is we're saying, well, if we already have 14 cups of red paint, where does that land at over here? How did I get to 14? Well, the number I'm multiplying by seems to be the batch number, doesn't it? Right? So if I take my 2 and I multiply it by 7 batches, that gets me 14 cups of red paint. So we would say this is going to be 7 batches. And if that's the case, then how many cups of white did she make? Well, I'll do the same thing to the other number. I have 7 as my bottom number, times 7 batches becomes 49 cups. Okay? And we can mark that out like this if we wanted to and do 7 times 7 is 49, 2 times 7 is 14, and we could draw that out in the double number line like so. Number 5. Find 3 different ratios that are equivalent to 3 to 11. Okay? So let's do it like this. I could do 3 to 11, and I can multiply both of them by 2. So 3 times 2 is 6, and 11 times 2 is 22. That's equivalent. I can multiply both of them by 3, right? 3 times 3 is 9, and 3 times 11 is 33. And I can multiply them both by 4, and we end up with 12 and 44. Those would all be equivalent ratios to the initial 3 to 11. Why are they equivalent? Because I'm multiplying both numbers by the same number. Okay? And number 6. Last one. Here is a diagram that represents the pints of red and yellow paint in a mixture. I have 3 and 1 and 3 and 1. Alright, select all the statements that accurately describe the diagram. The ratio of yellow to red is 2 to 6. Let's just see here. Yellow, do I have 2? Yep. And to red, 6? 2 to 6? Yes, that works out great. For every 3 red, 1, 2, 3, there's 1 yellow. Well, does that look right? Yep, sure does. 3 and 1, that works. For every pint of yellow, 1 yellow, there are 3 red. Yep, 1, 3. Works out great. For every pint of yellow, there are 6 red. 1, and no, that'd be like this, right? And that's not accurate. So that's a no. And the ratio of red paint to yellow paint is 6 to 2. So red, 6, 2, yellow, 2. 6 to 2, well, there's 6 red and 2 yellow. That is accurate as well. So we would say A, B, C, and E. All right, that is it for the day. Have a great day, and we'll see you next time.